All right, let's talk about storage today. Okay, so the module overview, the topics: Amazon Elastic Block Store, Amazon EVS, Amazon Simple Storage Service, S3, Amazon Elastic File System, Amazon EFS, Amazon Simple Storage Service Glacier. Okay. Or demos about the EVS console, Amazon S3 console, EFS console, Amazon S3 Glacier console. Okay. There's some labs working with Amazon EVS, and you guys know that all the labs are open. Okay. And storage solution case study. Okay. Now, after completing this module, right, you should be able to identify the 3 types of storage, explain Amazon S3, identify the functionality in Amazon S3, explain Amazon EVS, identify the functionality in Amazon EVS, perform functions in Amazon EVS to build an Amazon EC2 storage solution, and explain Amazon EFS, identify the functionality in Amazon EFS, explain Amazon S3 Glacier, identify the functionality in Amazon S3 Glacier, and differentiate between Amazon EVS, Amazon S3, Amazon EFS, and Amazon S3 Glacier. Right? Now, core services in AWS. Well, we saw Amazon VPC already, right? We saw Elastic Compute Cloud. It was a long class about compute. We saw some of the parts in identity and access management, IAM. We're going to see databases as well. And today we're going to see these 4. These 4 guys are so important in AWS. Okay. S3, EVS, and EFS, and Glacier. Remember that EVS stands for Elastic Block Store, not storage, store. Okay. Elastic Block Store. S3 stands for Simple Storage Service, and EFS stands for Elastic File System. Okay, very important. Right. Let's talk about Elastic Block Store, EVS. Okay, well, EVS, what it does is provides persistent block storage volumes for use with Amazon EC2 instances, right? And you can also use EVS volumes with RDSs, right? But mostly they're used with EC2 instances. And an EVS volume is like a virtual thumb drive, that you can plug into a computer and you can unplug it. So in AWS terms, you say that you can attach an Elastic Block Store to an EC2 instance or detach it, okay? Now, an Elastic Block Store can only be attached to one instance at a time. It cannot be attached to multiple instances, right? So if you want to use an EVS volume in another instance and it's already in use, you have to detach it from the instance that is attached to and then attach it to another instance, okay? Now, an EC2 instance can have multiple EVS volumes attached to it, right? So it's a one-to-one relationship coming from the EVS volume, right? Only one EVS volume or one instance per EVS volume, right? But it's a relationship. It's a one-to-many coming from the EC2 instance. So EC2 instance can have multiple or many EVS volumes. Okay. It's just like the thumb drive. You cannot plug in one thumb drive to multiple laptops, right? Unless you have an adapter or something, but this is not the case, right? So you will plug your thumb drive at one computer at a time, right? Same thing. So EVS store or EVS values or Elastic Block Store, it's a virtual thumb drive. Okay. Now, there's a concept between block storage and object storage. Okay. And when you see because the exam is about keywords, right? When you see object storage, that is S3. Okay. That is S3, right? Simple storage service, S3. When you see block store or block storage, that is EVS, right? Now, there's a big difference between them, right? And of course, S3 is cheaper than EVS, and I will explain why. Well, like it says here in this slide, if you want to, if you want to change one character in a 1 GB file, when it comes to block store, right, block storage, you don't have to update or modify the entire file. Okay, so the system itself, not you, the system itself, you change the character. That's your action, but behind the scenes, it's just going to that block where that file is, where that piece of a file is, and just modifying this block. Okay, which makes it faster and of course more expensive, right? Because it's better, right? Now, when you update a simple piece of a file in S3, right? What happens is that it has to update the entire thing, right? You have to update the entire file, and you're just only changing one character in the file. Okay, so that's the disadvantage of object storage as opposed to block storage. Okay, so when you compare both of them, you realize that this guy is much quicker than this one, right? Because it only updates the block where that piece of the file is. But for object storage, it has to update the entire thing, the entire object. Okay. And when I say object, I'm saying a file because S3 stores objects, right? And by object, I mean files, videos, pictures, any type of file. Okay. Now, when you have EVS, right? When you use EVS, that's something that you can do with EVS, and simply you can create volumes. Okay, you create volumes. So something in the Ec2 instance dashboard that you can say says volumes. You can click on it, and you can create a volume. You can select the volume type. If you're gonna use SSD or HDD, and how many gigabytes you're gonna use. And then after it's created, then you can attach it to an Amazon EC2 instance. Now, you have to make sure that the volume is created in the same availability zone as the EC2 instance. Otherwise, it will not find it. It will not find it. When you try to attach that volume to the EC2 instance, if this guy, the EC2 instance, is not, let's say, in US East 1A, right? Because the volume was created in US East 1A, availability zone, it would not find it. So they have to be in the same availability zone for them to work together, okay? And then once you find it, you can attach it, and that's it. The volume is going to be mounted right there. It's going to be attached to the instance. Now, also, like we said before, EVS offers block level storage. This is a key word, guys, a key word for your exam, okay? And it's a very good thing that you start taking exams as soon as possible, because, there are 12 exams and there's a lot of content. So you don't want content to pile up and then, not to have time to study before the exam. Okay, so volumes are automatically replicated within its availability zone. Okay, so they're available, right? But they're not highly available. Okay, because they're replicated in the same availability zone, right? Now, when we see object storage, right? Object storage. When you upload a file in S3, S3 will replicate that file in 3 different availability zones, which makes object storage more highly available than EVS volumes. Okay? Now, if you want to back up that EVS volume, what you can do is just take a snapshot of that EVS volume, right? And then that snapshot, which is um, a point in time, right? Like a picture, like a frozen image, a point in time of that volume, and store it in Amazon S3. Because the best place to store snapshots, backups, logs is Amazon S3 because it's highly durable. It's durable and highly available. Okay, so the best place to store all of these things is Amazon S3, and we're going to see it later. Okay. Now, EVS volumes include boot volumes and storage for Amazon Elastic Compute Cloud instances, right? Also, data storage within a file system, database hosts, and enterprise applications. So it can be used for all of this. These are the use cases, some of the use cases of EVS volumes. Okay. Now, this is something that you guys need to remember. The types of volumes, right? The types of volume. We have 2 types, right? We have solid state drives, right? Solid state drives and hard disk drives, also known as SSD and HDD. Now, you have to know the different types that you can find on the disk categories, right? And then we have 2 categories and we have 4 types. So we have general purpose, right? Also known as GP2, right? We have provisional Iops, throughput optimized, and code, right? Code. Now, the maximum Iops, and Iops is input output per second, that the general purpose can have, the maximum size is 16 TB bytes. Okay, this is not terabytes. This is TB bytes, right? Which is a little. If we go here and we convert TB byte to terabyte, right? And then we can say that one TB byte is 0.9, right? So we can say that 1 TB byte is a little bigger than terabyte, right? We can go opposite ways, and we can say the 1 terabyte is 0.90 TB byte. Okay. So basically, the TB byte is a little bigger than the terabyte, right? Right? It has more value. It's like saying $1 is, or €1 is 132 American dollars. So like the euro has more value than the dollar, right? So, but that's the measurement that is used for storage, right? In AWS. Okay, so we have 16 TB bytes. Provisional Iops is 16 TB bytes, and you can see that all of them have the same maximum volume size. Okay, but when it comes to Iops, volume maximum, right? General purpose is 16,000 Iops, right? And that is, right? That is the highest it can go, right? If your application needs more than 60,000, then you have to use a provision Iops, okay? Provision Iops. And of course, guys, this is gonna be more expensive. SSD is gonna be more expensive than HDD, right? Whatever you go, even your computers, SSD is gonna be more expensive than HDD, all right? Now, provisioning IOPS, the highest you can go is 64,000, right? Throughput optimized is 500, and cold is 250, right? For cold, well, the worst is it? It's just not frequently accessed. That's why is cold, right? Now the maximum throughput, right, per volume is 250 megabytes for general purpose. My God. 1,000 megabytes per second for provisioning IOPS, 500 megabytes per second for throughput optimized, and 200 megabytes per second for code. If we just compare megabytes to megabytes, we're gonna realize that it's the same thing, but you know, it's a smaller measurement. Okay. It's not exactly the same, but it's higher than megabytes, right? So that's the types. Don't forget general purpose, provisioning IOPS, throughput optimized, code. And we're gonna see when they are used, the use cases. But these are the four guys: general purpose, provisioning IOPS, throughput optimized, and code, okay? Now, the use case. Okay, when do we use general purpose? Well, the word says it all, right? It's for general purposes, right? So this type is recommended for most workloads, right? So whenever you wanna use, it's for any type of workload as long as the IOPS are less than 16,000, right? The input output per second is less than 60,000, you can use it, right? It's for system boot volumes. You can boot your system with this volume. It can be used for that, right? It can also be used for virtual desktops, right? And virtual desktops, there's one service in AWS. It's named Workspaces. Workspaces. AWS, right? Workspaces. This is the desktop as a service solution of AWS. Is just virtual desktops, and it's highly scalable. You can have as many desktops as you want, right? And they can be used for these guys too, okay? For these desktops, virtual desktops, right? Low latency interactive applications, development and test environment. So you can use this guy for these uses. Okay, provisioning IOPS. Well, this is a little more high-end volume type, right? It's used for critical business applications, you know, applications that need a lot of throughput, right? A lot of provisioning IOPS that requires sustained IOPS performance or more than 16,000. Remember that this guy is up to 64,000, okay? And or 200 megabyte per second of throughput per volume. This guy has 1,000 megabyte per second, right? And it does need more than that, right? And for large database workloads. So of all these guys here, right, the most expensive one is provisioning IOPS, okay? That's the one that, you know, is for high-end critical business applications. Okay. Now, throughput optimized is for streaming workloads that require consistent fast throughput at a low price. So it says it all here. When you pass this line here, then it's when you start saving money, right? But the quality is not as good as this quality here, right? Now, this is for sustained IOPS performance. Guys, the keywords for the exam come from these guys, okay? Come from this table here. So we have sustained IO's performance right here, and here consistent fast throughput. Okay, so consistent fast throughput, that could be a keyword for throughput optimized. And remember throughput optimized. Now, big data, when you're working with a lot of data, right, you can use throughput optimized. Data warehouses, you can use this with Redshift when we see databases and all that. Log processing, and it cannot be at boot volume. So something that you need to remember is that these two guys cannot be at boot volume. These two can be, right? Now, cold, well, like I said before, it's infrequently accessed, right? And it's very cheap compared to the other guys. This is the lowest storage cost, right? And when do you use this guy? Well, it says it here. Scenarios where the lowest storage cost is important. So if cost is important, right, and you're looking to save some money and you don't need to access this data frequently, then cold is the guy, right? This is throughput-oriented storage for large volumes of data. This is for large volumes of data. See that it is not for small volumes of data. It's for large volumes of data, but the data is not frequently accessed and is cheaper than the other solutions. And of course, it cannot be used for boot volume, okay? Now, there's some features of Amazon EVS feature, AWS, and I will show you later how to do that. You can have snapshots. You can create a new volume from the snapshots, right? You can encrypt the volume when you create the EC2 instance, or you can just create a volume, encrypted volume from a non-encrypted volume. That's possible too. There's no additional cost when you encrypt the volume, right? Now the volume is elastic block store, right? Increase capacity and change to different types, right? You have types here that you can change. You can change from one type to the other, right? So those are some of the features of EVS. We also have the volumes, IOPS, and pricing here. Now, Amazon EVS volumes persist independently from the instance. So they don't need to be attached to an instance, right? They can be detached to an instance, of course. If they're detached, they have no purpose. It's not in use, right? It's just available, right? They will always be functional when they're attached to an instance, right? But they can persist, independently from the instance. They will not disappear when the instance disappears. It's just like your thumb drive. If your computer breaks, you still have your thumb drive, right? But your thumb drive, without being plugged in, is useless, right? It's useless. All volume times are charged by the amount that is provisioned per month, right? And something very important, guys, if you have an EC2 instance that is running, and if you stop the instance, you're still going to be charged for the storage. So that EVS volume that is attached to the instance, you're going to be charged for it. So one of the ways to save money, if you're not using your instance, but you still need it, is stopping the instance. You're going to save on compute. You're going to save on compute because you're not computing. It's not running, but you're going to be charged for storage. Okay, two different things, compute, storage. Don't forget there are three main factors for cost in AWS is compute, storage, and outbound transfers. Okay, so storage, you're going to be charged for that. Okay, now IOPS, general purpose SSD, you're charged by the amount that you provision in gigabytes per month until storage is released. Yeah, until the volume is released, right? If the volume is touched to an instance, you're going to be charged for that. Magnetic that's another type of storage. there's a previous generation volume types, right? Standard workloads is frequently accessed, 1 gigabyte or 1 terabyte. Max IOPS per volume is 40 to 200. That's too low. Max throughput per volume is 40 to 90. Very low. And it can be a VOOT volume. It's just a previous generation one, but they still mention it, right? If you still have it, where you're going to be charged by the number of requests to the volume, right? Now, provisional IOPS, we know that one. Input output per second, right? You're charged for the amount that you provision in IOPS multiplied by the percentage of days that you provision for the month. Okay, so you're gonna be charged by IOPS, right? Multiplied by 5 days, for example, or the percentage of days in 30 days. Maybe let's say that if you use it 4 days, that's gonna be probably 25% or close to 25%, right? Multiplied by this IOPS that you're using, right? Actually, it's not. It's 7 days. That will be close to 25% of the month, right? 7 by 4 is 28. So it's very close, right? All right. So, snapshots and data transfer. Well, there's some added cost of Amazon EVS snapshots to Amazon S3 is per gigabyte month of data store. So remember that right now you have 5 gigabytes of storage for free for 12 months, right? For 12 months. When your free trial is over, then whatever you store in Amazon S3, you're going to be charged per gigabyte per month, right? So when you take a snapshot of the EVS volume, you will want to store it in an S3 bucket because it's very durable. And we're going to see that later. So you're going to be charged for that, right? For snapshots. And you want to save your snapshots, right? Data transfer. Inbound data transfer is free. We learned that already. Anything that comes in, you're not going to be charged for it. But when you send something out across regions, that incurs charges, okay? Remember that transfer out, it's you have to pay for it unless it is a transfer within the same region among your services. Okay. So, what are the takeaways of this section? Well, Amazon EVS features. We have persisting and customizable block storage for Amazon EC2. SSD and SSD types. We have these types with 4 different categories, right? Which are what are they, guys? Can you tell me the four categories on these 2 types, HDD and SSD? What are the 2 categories of SSD?
General purpose.
General purpose and
Provision.
Provision what?
IOPS.
IOPS, okay? IOPS. And how about HDD?
Code.
Code and
Throughout throughput optimization.
throughput optimized.
Optimized, sorry.
Optimized. Okay. Remember that it's replicated within the same availability zone, right? And it's easy and transparent encryption, elastic volume, right? And backup by using snapshots. Okay. Do you guys have any questions?
Can you refresh my memory? What are snapshots?
Snapshot is an image. It's just an image of an EVS volume in time, right? You want to save all the data until that particular time, up to the moment where you take the snapshot. You take a snapshot of that volume, and then you save the data until that moment. It's like an image. You take an image of the volume, and then you can use that snapshot to create another volume, which is exactly the same as the volume previously. Okay, it's just an image. It's like I can do this, for example. You see, this is my computer, right? This is a snapshot. of this image, right? I took the image and I can show it to you here. You see? It's a screenshot, right? A snapshot, right? But in that case, it's of a volume that contains data. So I cannot do anything with this. I can just show it to someone, but I cannot reproduce my PowerPoint with this, right? I can't. But with the snapshot, I can reproduce my volume from the snapshot. Okay? So I can share that volume, that snapshot with someone in another account, and they can reproduce, they can create a volume from that snapshot. Okay? You understand what I'm saying? Hello? You understand what I'm saying?
Yes.
So if a disaster happens, if something happens, like something happens, you lose your database, you lose your EBS volume, I don't know, something happens. So if you still have the snapshot, you can reproduce your EBS volume again, and you didn't lose anything. The only thing that you lose is whatever data that was stored after the snapshot. You're gonna lose that data, right? Because the snapshot just gives you the data until that moment when you took the snapshot, okay? And we're gonna see how to do it, okay? So here we have a recorded, I can show it myself, but I have this guy here. So that's gonna be much quicker, okay? Let me just play this guy.
Welcome to the demonstration on provisioning an elastic block store volume, also known as EBS. As with other AWS services, we first need to verify that we're in the correct region. We want to be in the same region as the EC2 instances that we're going to attach the EBS volume to. Once we've verified the region, under the Compute section, select the EC2 option. This will bring up the EC2 dashboard. On the left-hand side, if we scroll a little ways down, you'll see the Elastic Block Store. We're going to select on the volume option, which is going to allow us, it's going to show us the volumes that are associated with this account in this region, but it's also going to allow us to create a volume. The first option it's going to present us with is it's going to ask us what type of underlying drive do we want to use for our EBS volume. We're going to select we have the option of general purpose SSD, which is the default and which will work for most workflows. If we have a workflow that requires guaranteed IOPS, we would want to select a provisioned IOPS and provision a certain amount of IOPS. If we have a workflow that is cold storage and not being accessed very frequently or does not require high throughput access, we might select cold HDD. If we have a throughput optimized workflow where we have large amounts of throughput, not high IOPS, we would select the throughput optimized HDD, or we may elect to select just bulk magnetic storage. For the demonstration, I'm going to leave it with the default of general purpose SSD. The next option is how large of a volume do I want to provision? We can go as small as 1 gigabyte or as large as 16 terabytes. For the purpose of this demonstration, I'm going to create a 10 gigabyte volume. We also see for general purpose SSDs, there is a baseline of 3 IOPS per gigabyte with a minimum of 100 gigabytes, and the volume can burst up to 3,000 IOPS per second. Next, we need to select the availability zone. We need to select the same availability zone as the EC2 instance that we're going to attach this Elastic Block Store volume to. In my case, I need to select US West 1B. If we had selected throughput optimized hard drive, it would give us the information about the throughput for the volume we were creating. If we want to choose to create a volume from an existing snapshot, we would select the snapshot here. If we want to encrypt the volume, we would select the option here. Or if we want to create tags for the volume, we would create those tags here. I'm going to leave the rest of the options as default and create the volume. As you can see, the volume's been created. We have the volume identifier. We can close this window. And here you can see we have our 10 gigabyte volume. I can select that volume and I can attach that volume to an EC2 instance. I select on the instance, it shows me the instances available in this availability zone. I select which EC2 instance I want to attach that volume to, and it tells me it's going to create a device on that EC2 instance called /dev/SDF. Go ahead and attach that volume, refresh the page, and we can see the volume is now attached. If I open up an SSH window to the EC2 instance, if I do an ls-l on/dev/SDF, you can see that that volume has been created. And you can see that it's a link to a device called NVMe1N1. Now that we've attached the volume, we need to make a file system on that device. We need to tell it what type of file system and give it the device name. The file system's been created on that device. Now we need to mount that device on the operating system. First thing we need to do is create a mount point. I've already created a mount point called mnt/evs. You can see that here. The command to mount it for the Unix is mount the device name, and then the mount point. As you can see, our volume has been mounted onto this EC2 instance. Going back to the menu, I can now choose, I can create a snapshot of that volume. I can detach that volume. I can delete that volume. I can modify it, increase the size of it perhaps, and a number of different options.
Nice. So that's the demo of EVS volumes. Do you guys understand how it's done? I can do it again later.
Yes.
Okay, yes.
Okay, so there's a lab that says working with Amazon EVS. That's already open for you guys. So that's something that you need to work on, right? And the lab is designed to show you how to create an Amazon EVS volume. After you create the volume, you will attach the volume to an EC2 instance, configure the instance to use a virtual disk, create a snapshot, and then restore from the snapshot, okay? So from the EC2 instance, you have an EVS volume. From the volume, you create a snapshot. And from the snapshot, you can restore that volume. The final product is going to be this one, okay? Now, let's talk about Amazon Simple Storage Service, Amazon S3, right? Well, like we said before, it's an object level storage, which means that if you want to change a part of a file, you must make the change and then re-upload the entire modified file. So Amazon S3 stores data as objects within resources that are called buckets, right? So you will now learn more about Amazon S3, okay? So a bucket is the container, if you could call it that way, container or resource where the objects are gonna be stored, okay? So, like it says here, data is stored as objects in buckets, right? So buckets are virtually unlimited, right? They're virtually unlimited, right? So it means that you can store as many objects as you want, right? You can store as many objects as you want, but there's a limit per object, per single object, and it's 5 terabytes. Okay, so your object cannot exceed 5 terabytes, right? But you can just store as many objects as you want. There's no limit. It's unlimited, right? So it's highly scalable, right? Now, something that you have to remember, guys, is that it has an 11 nines durability, right? It means that some people have compare that to losing one thing every 10,000 years. So it's super, super highly durable, right? You will have granular access to buckets and objects because you can have something called a bucket policy that you can allow or deny access to a bucket or an object, okay? So it's very granular, right? Something that differentiates S3 is that S3 is not associated with any server, okay? So the good thing about S3 is that you don't have to attach it to anything. It lives on its own. It's independent. EVS volumes, they need to be attached to an instance for them to live, for them to be used, otherwise they will be useless. These guys, they can be independent, right? They're independent. You do not need to manage any infrastructure yourself, right? And you can put as many objects in Amazon S3 as you want. Amazon S3 holds trillions of objects and regular peaks at millions of requests per second. Millions of requests per second. Objects can be any data file, images, videos, server logs, any data file. Amazon S3 supports objects as large as several terabytes in size. The limit is 5 terabytes, right? It provides low latency access to the data over HTTP or HTTPS. So you can retrieve the data from anywhere, right? From anywhere at any time, right? You can also access S3 privately through a virtual private cloud VPC endpoint, okay? Only through the endpoint, right? You can also use IAM to see who controls your buckets, IAM policies. And also you can use, like I said before, Amazon S3 bucket policies, right? Or you can have a control list per object. So different ways to control your bucket and your objects, right? By default, none of the data is public, right? The data is not public, right? It's private by default, right? You can encrypt your data in transit and choose to enable server-side encryption, right? The buckets, you can enable server-side encryption in it, right? You can also access S3 through the web-based management console, the console of AWS, right? The APIs, the SDKs, or you can access them also with a third-party solution, which use the API or the SDKs. Amazon S3 includes event notifications as well that enable you to set up automatic notifications when certain events occur. When someone uploads an object to a bucket or deletes objects from a specific bucket, those notifications can be sent to you, or they can be used to trigger other processes, such as like a Lambda function. You can trigger a Lambda function, right? A Lambda function would perform an operation for you. So as you can see, it's a very heavy duty storage solution. Right. Now, Amazon S3 offers a range of object level storage classes that are designed for different use cases. So a standard, and it's something that you guys need to take note of, because you're not going to see it in the slides that much. But you know, a standard S3, right? It's designed for high availability and high durability, and also for performance object storage for frequently accessed data. Okay, so this is for frequently accessed data. Now it has at 11 nines and 11 nines durability and 4 nines availability. So it will be 99.99999 11 nines durability and 4 nines availability. It means 99.99. So it's going to be 99.99 of the times it's going to be available. Okay. It delivers low latency and high throughput, so it's appropriate for a variety of use cases, including cloud applications, dynamic websites, content distribution, mobile and gaming applications, and big data analytics. So it's good for that, right? Now we have the case of Amazon S3 intelligent tiering, which is quite new from last year only, right? And this, guys, is a storage class that is designed to optimize costs by automatically moving the data to the most cost-effective access tier without performing impact or operational overhead. So the way that this guy works is that if it just perceives that the data is frequently accessed, well, is that smart to move it to the standard, the S3 standard, because this is for frequently accessed data. So this guy will move it to this guy. Right? So for small monthly monitoring and automation fee per object, Amazon S3 S3 Intelligent Tier monitors patterns of objects in Amazon S3 Intelligent Tiering and moves the objects that have not been accessed for 30 consecutive days to the frequent access tier, this one here. So if the objects have not been accessed frequently for 30 days, it moves them to here, to the frequently accessed S3 standard storage class. If they are frequently accessed, then it moves the objects to the S3 standard. So the difference between these two, the first one and the third one, is that this one is frequently accessed, first one, and the third one is infrequently accessed, right? And that's why it's called Amazon S3 Standard IA, infrequently accessed. Now, the first one and the third one, they have the same durability, 11 nines, but the availability, as you can see here, is frequently accessed. You know, as it is frequently accessed, the availability is going to be less, right? So it's going to be 3 nines, 99.9. Okay, so the first one is 99.99 availability, and the third one is 99.9, 3 nines availability, right? That's what S3 intelligent tiering is going to do. It just follows the patterns. So you want to save on cost. You don't want to have here an object that is not frequently accessed here. So you want to move it here, right? And this guy is the one that monitors and automatically moves it here, right? And you can save on cost, right? Now you have one that is even less available, is the one zone infrequent access. Don't forget that S3 by default will replicate the data in 3 availability zones, right? So that makes it highly available. But this guy, it's only one zone, right? Only one zone. So it's called S3 one zone infrequent access. Now this guy will have also have 11.9 is durability, but the availability is going to be even less, lower than these two, right? This is going to be 99.4, okay? 99.4. Don't forget 99.99, 99.9, 99.94, or 99.4, right? That's the availability, right? We also have Glacier, which is for archiving. Okay, this is a very cheap solution, you know, because it's cold storage. It's cheap. So you want to save on money, the Glacier is the guy. But for retrieval, it's gonna be not as immediate as these guys, Standard 3 and these guys, and it's gonna be more expensive to retrieve these guys because they take more time, right? So whenever you hear the word archiving, that's Amazon S3 Glacier, okay? So to keep the cost low and at the same time suitable for varying needs, S3 Glacier provides 3 retrieval options, right? That range from a few minutes to hours, right? And we're gonna talk about those later, right? So you have something called lifecycle policies in S3, right? Where you can move the objects from one class to the other, right? So one class to the other, just in case you want to archive the objects after 1 year, for example. You don't want them to be in S3 all the time. So based on age of the object, you want to move them automatically from one class to the other, right? Let's say that after 30 days, you want to move it automatically from S3 to S3's as standard infrequent access, right? And after 60 days, you want to move it to Glacier, right? And after 365 days, maybe you want to delete it, right? So that's called a life cycle policy. And I'll show you that later, okay? So you want to just dispose of that object after a year, for example, then you can create a life cycle policy and work on that. You just create it, you know, configure it, select the storage classes you want the object to go to after a certain period of time, and then forget about it. It will happen automatically, okay? Now, well, we also have this guide, which is even more inexpensive than the other ones. This is even more archiving than Glacier. It's gonna be there more time. You know, that can be up to probably, let's say, it's the lowest cost storage class that Amazon S3 has. It has a long-term retention and digital preservation for data that might be accessed once or twice a year. So just in case you have items that are accessed once or twice a year, what would you have them here? This is for frequent access, right? So put them in one that, you know, it's very cost efficient, right? So this one is designed for customers, particularly customers in high regulated industries, such as financial services, healthcare, and public sectors that retain data sets for 7 to 10 years or more to meet regulatory compliance requirements. So it can be used for backup and disaster recovery as well. It's easy to manage. It's an alternative to magnetic tape systems, right? It complements Amazon Glacier. I would say that this guy is the oldest brother of Glacier, right? And it also provides 11.9's durability. By the way, all of these guys, all of them provide 11.9's durability, right? And they're replicated and stored across at least 3 geographically dispersed availability zones with Glacier and Glacier Deep Archive. And these objects can be restored within 12 hours. So let's try to see the retrieval options that Glacier has, right? So let's just get it from here. Let's see what it says from here. Well, we can see that it has, I want to show it to you guys. It has expedited, standard, and bulk. Okay, guys, this is very important. And I will paste it on Slack because this is important. Okay, so I'm going to put it on Slack for you guys. I consider this super important, right? Right? Right. So that's important. Okay. So expedited, the thing that we are interested here is the retrieval time, and it's between 1 and 5 minutes, right? And that's for both Glacier and Glacier Deep Archive. Okay, that's for both. 1 to 5 minutes. The shorter the time, the more you're going to pay. Okay, so the difference between Glacier and the other guys is that you can get your objects immediately with standard S3, infrequent access, standard S3, one zone, infrequent access, all those guys, you get it immediately, right? That could be a keyword in the exam. If it tells you that it takes hours or minutes to get it, that would be Glacier, right? That will be Glacier, because with the other guys, it's immediately. It doesn't take minutes, it's immediately. Okay, so standard will be between 3 and 5 hours, right? And bulk would be between 5 and 12 hours. That's why I said that you're gonna get your objects within 12 hours, which is the maximum it can get for you to get the object. Okay, so if it says within minutes or within 12 hours, that's Glacier, because the other ones are immediate. Don't forget about this retrieval options from S3 Glacier. Okay, don't forget that. That's very important. Okay, so how do you load something in S3 bucket? Okay, you can simply go there, go to the bucket, right? Create a bucket and load any number of objects. I can load a bucket, an object from the CLI. I can update an object, or I can upload an object in an S3 bucket from a Python program by simply having the URL of the bucket, right? Which is the URL endpoint, is the endpoint. Usually the URL, the bucket path style is first you have S3 the region where the bucket is, Amazon, AWS.com, and then the name of the bucket. Okay? Or a hosted style, this is a path style, and this is a hosted style. You're gonna have the bucket name first, right? The bucket name first. And basically, if you take a look at both of them, basically what you're doing is just moving the bucket name to the beginning of the URL. That's basically it. So you can have the bucket name at the end, or you can have the bucket name at the beginning. Okay? So they're both valid URLs, but one is the path style and the other one is the hosted style. All right? So Amazon S3, bucket, and then you have the file here. This is an MP4 file, and it's in the Tokyo region, AP Northeast 1. Okay. Now, it's very redundant. Like we said, it's just replicated in three different dispersed availability zones. Okay, and don't forget that availability zones, they are separated like 50 to 60 miles from each other. So that's for isolation, just in case of disaster, right? So you want to make sure that your resources are still available when you put them in different availability zones. Okay, so you see here that the same file, the welcome dump MP4 file, was uploaded into a bucket and it was replicated into facility 1, 2, and 3, and then you are highly available. And this is within the same region. Okay, within the same region, super highly available. 3, if one, if one AZ goes down, you still have 2. Okay, that's the good thing about S3, the redundancy that it has, or that it provides. Okay, it's super highly scalable, right? So you can just basically upload as many objects as you want. So you can upload, you have this guy here, welcome MP4, prod 2, MP4, prod 3, 4, 5, 6, 7, 8, whatever you want, it's going to be highly available. But don't forget something, you're going to be charged per gigabyte per month. Okay, so that's something that you guys have to keep in mind for the exam and for your lives, right? That storage is, you have to pay for it. Okay, now, how do you access the data? Where? From anywhere. You can use the console, you can use the command line, or you can simply use the SDKs, right? API calls, right? Software development kits. So let me see if I can just log into my my console. Okay, so I'm gonna come here and just log in. See if I can log in here, right? And let me get my code. And access my console. So I'm gonna come to S3. You can come to S3 through the services here. You can just mark it here and have it here in the corner, and just access your bucket, right? And create a bucket. As simple as that. So I can give it a name. The name has to be unique. It's a global name. Don't forget this. Saturday class bucket. Okay, so I'm gonna choose a region. Even though I have to select the region, my service is global. Okay, this service is global because it can be accessed from anywhere, right? So I'm gonna leave default, like, US East 1, and by default all the public access would be blocked. Okay, so it's private by default. I can unblock this, right? I can make it public, but it gives you a warning, right? I'm gonna keep it private, right? I can have versioning, which we can explain later. I can enable server-side encryption, so I want to make it enable. I want every single object that is, what is this? I want every single object that lands or uploaded in my S3 bucket to be encrypted, right? And I can have some more advanced settings here, but I'm gonna create the bucket. So the bucket has been created, right? And then I can come here and upload any type of object I want. So I can upload any object here. It's just like any upload features in any computer or anything. So I want to just upload something here, maybe maybe this guy here. I want to upload it, and that's it. It's uploaded. You see, I'm going to upload it, and it took less than 2 seconds to upload. Okay, so now I access this from the console, right? I can come to the command line here, right? And remember, guys, that we we set up the AWS CLI before, remember, with AWS configure. We did this before, right? Where you put your access key, secret access key, and then the region, and then the format, okay? We did this before. Now I can just access my bucket by simply say AWS S3 LS, right? And I can have my bucket there, right? I can have my bucket there, okay? I can come to, and I can make a bucket if I want to. I can say AWS S3 and then give it a name, right? Give it a name. So I can say Dunieski Saturday class bucket 2. Remember, it has to be unique, right? I made a mistake. I forgot to put the operation. I have to put the operation, which is make bucket, right? So now I created a bucket. I can do ls again to check, and there are 2 buckets now, okay? And if I go to the console, right? If I go to the console and I just refresh this page, right? I can refresh this page and I will see that I have 2 buckets now, okay? 2 buckets now. Now, I can upload a file, any file I want. So I can do ls. Let me see, what do I have here? ls, I have this ACI bonded zip. So I can say AWS S3, right? S3, and I can say copy, and then I can say AWS CLI bundle zip, right? And then I could put the bucket where I want to send that. The bucket where I want to send that guy, right? S3, like this. So I can say I want, I'm sorry, that's not the guy. I want that to be in the second bucket. So Dunieski, that's Saturday, that class, the dash class, that bucket too. Okay, so I'm gonna load that file there. Completed. It's just working on it. Remaining, it's uploaded. Now I can just check in my bucket and the file is uploaded. Okay, so that's what's from the CLI. I can go to my Python program that I have here. Okay, I have a Python program here that I can take a look. It's just opening here. Let's see if I can find that guy. I think that I got this guy here somewhere. One moment. I think it's this one. Okay. So let me copy this. Let me copy this guy because these are the keys that I need, right? And let me create a new file. Okay. Let me create a new file. And let me name it well, actually, I can use the same thing. I can use the same guy. Okay. So I can open I can say here test.python. Right? I can copy this guy. Right? Right? And I can just run it. have to. Okay. Okay, so now I can test it, see what happens. Okay, I don't get it anything, that's fine. So now I can say, for example, I can say system, and they'll do the same, AWS S3 LS, right? And then I get this guy. Okay. Not getting anything. System LS. Okay, because I haven't saved it. Okay, not a problem. So I get the buckets here, right? I get the buckets here. So I can do the same here. I can use some Python code if I want to upload something. Let's say that I want to upload, maybe I want to upload, let's see, I want to upload this. Just an example, guys, for you to know what I want to do here. Okay. So I can just put this here, right? And maybe I want to create a file. So I can say system. I'm using Linux, okay? I can say touch Saturday.txt, okay? So now if I run this, well, first I have to save it, okay? If I run this, then it creates this Saturday text here. You see here? It creates it, right? Now I just comment this guy, and I'm gonna just uncomment this guy, which is Python code. I'm gonna copy the bucket that I want to save it to, right? So I'm gonna copy here, right? And the file is Saturday.txt, so I'm gonna put it here, right? Right? That's gonna be the file. And I'm gonna put it here in the key as well. Okay, I'm gonna bring this code to print the object once it has been uploaded. So I'm gonna come here, click enter, and then this for loop to bring it. Guys, you don't need to know this. This is just for you guys to know how it can be used from this SDKs, okay? So now I can just save it and run it. And then I get that the bucket will just upload that, and it shows that it's being uploaded. It shows here, okay? Now, if I come here to my guy and just refresh this guy, and I see that Saturday has been uploaded from the SDKs, okay? So you can see, guys, that this is possible. This is possible to do it from the 3 different places that AWS is telling you here, okay? From the console, from the CLI, and from the SDKs, okay? Now, common uses of S3, well, it's used for storing application assets, static web hosting, backup and disaster recovery, right? Staging area for big data, and many more. So guys, one of the key words for S3 bucket is static websites, okay? So if you want to host a static website with the lowest cost, S3 is the guy for that, okay? So those are common uses for that. Also, the best place for backup and disaster recovery, S3. okay? Storing application assets, images, HTML files, CSS files, videos, you know, anything that you want, you can store there. Okay. Common scenarios, well, backup and storage, application hosting, media hosting, software delivery. Okay, so all these guys, they will just be, you know, store these guys here. Mobile application assets, software delivery, media hosting, backup and storage. So many things that you can do. There are many companies that use S3. Okay, so sometimes, for example, there's a company called ADT. This is for monitoring and securing your house, right? They have some memberships and they say that they store your videos in the cloud. Okay. When I think of that, I can think about S3 very easily. So your videos can be in S3. Of course, it's not going to be there forever because remember, when you store something, first of all, you're not going to need it forever if there's nothing important, right? And second, you're going to be charged for storage. So after 30 days, delete it, right? Now, pricing, you pay only for what you use. If you don't use it, you don't pay for it. You're going to be charged for gigabytes per month, transfer out to other regions, and for put, copy, post, list, and get request, okay? Put is just about update, right? Update, and copy. Put is like post, similar, but it just modifies the file. Copy is copy, post is just upload, right? And list is just to see. That's what we're doing when we do ls, right? This is list, right? That's list, right? And also for get is when you get the object from the bucket. Okay, you don't pay for transfer in to Amazon S3, and also you don't pay for any transfer from Amazon S3 to CloudFront or Amazon EC2 instances in the same region. Okay, in the same region. If it is another region, yes, you get paid. You get charged for that. Well, we said here that depending on the availability, you're going to be charged, right? Standard, like we said before, is S3 standard. It has 11 nines durability and 4 9 availabilities. Okay. S3 standard infrequent access is designed for 11 nines and 3 nines of availability. And guys, if you don't know this concept of 4 nines is 99.9, 99.99, and 3 nines is 99.9. The amount of storage, of course, the number and size of objects, you're going to be charged for that, right? That makes sense, right? Request, the number of type of request, if it is a get, a put, or a copy, right? The number and the type, right? The type of request, different rates to get, request, and other requests. Of course, you're getting the object from the bucket, so it's gonna be a different rate, right? Data transfer, the pricing is based on the amount of data that is transferred out of the Amazon S3 region. Okay, data transfer in is free, but you incur charges for data that is transferred out. Okay, we know that already. So for you to know this a little bit better, the method, this type of request, get is when you retrieve an object from Amazon S3. So for this, you must have read access to use this operation. For put, you add an object to a bucket, you must have write permissions on a bucket to add an object to a bucket. Okay, and copy, it creates a copy of the object that is already stored in Amazon S3. A copy operation is the same as performing a get and then a put. Okay. takeaways here. Amazon S3 is a fully managed cloud storage service. You can store a virtually unlimited number of objects. You pay for only what you use. You can access Amazon S3 at any time from anywhere through a URL. Amazon S3 offers rich security controls. Okay. Now, if I give you guys, if I give you this URL, and I want you to test something, just see. Let's see if I can find the. I'm gonna give you this guy. Okay. I'm gonna give you this guy. So try to download it in your computers, guys. Try to download it and see what you get. Let me know what you get. Guys, let me know what you get.
69.
Get an arrow.
Right? So by
Error.
default, my bucket is private, right? So what I can do here is just try to make it public. Okay, so I'm gonna make it public. Try now.
Yeah, the file doc.
Saturday test is the name of the file.
Can you see it?
Yeah, we see it.
It downloaded.
You see? So by default, the bucket is private, and then you can make the object public. Okay. So the one that you got was Saturday TXT, right?
Yeah.
Okay. So this guy, I just unblock the public access, right? I just did this. This is not completely good. It depends on the type of data that I'm storing. Okay. Now try again, please. Try again, please.
No, didn't get it this time.
See? Okay. Okay. Really? I am the root user. How in this world I don't have permission to do that?
Did you take away your own access?
No, you can't. You can't take away any privileges from the root user. You cannot control the privileges of the root user. Let me see something.
So if you're moving from Azure or Box into S3, or you're only paying for the data out, the
Correct.
transfer out, right?
Correct. I didn't have permission, not because I don't have privileges, it's because all the public access was blocked. So I cannot specifically override a permission. So I have to unblock that. So if I just block this and this and this, So guys, try now. Let's see what happens. Try now. Let's see what happens.
I can
Can
download.
download.
Downloaded.
Downloads because I gave you access only to read, but you cannot list or write. Okay. So I have granular permissions here. Okay. I can give it to a bucket owner. That's my account, right? Of course, I can list, write, read, and write. That's me. Why would I take away, access away from me, right? You cannot, at the account overall, you cannot reduce your privileges in the account level, but you can reduce your own privileges here, right? But you don't want to do that. Why? Right? Unless you have, unless someone is bipolar and may have different personalities or something, and maybe you want to protect yourself from yourself. I don't know. Why would this happen? You can just give it to a group, a users group, right? You do whatever you want, guys. Right? All right, so you can access Amazon S3 at any time from anywhere URL, and you can. Amazon S3 offers rich security controls. Okay. All right, let's watch this demo.
For this demonstration, we're going to create a simple storage service, also known as S3. In your AWS Management Console, you can type in S3 in the search bar or scroll down to the storage section and select S3 from the menu. This is going to bring up your S3 console. In the S3 console, you can see existing buckets in this account, and it'll tell you some information such as what region this bucket was created in, when it was created, and whether it has public access. For this demonstration, we're going to click on the Create Bucket option. The Create Bucket window pops up, and we have to enter in a DNS compliant bucket name that is unique across all of AWS. We next select the region we want to deploy this bucket in. For this demonstration, I'll leave it in Northern California. The last option on this menu is if we have a bucket that has some settings that we want to copy for this new bucket, we can select that older bucket now. Otherwise, if we have no other changes we wish to make, we can simply click on Create, and it will create the bucket with all the default settings. For this demonstration, we're going to walk through the different options and the different sections, so I'm going to click on the Next button. Here we have the options to set some of the properties, such as enabling versioning, enabling server access logging, creating tags to put on the bucket, enabling object level logging, and setting up default encryption for all items that will be written to the bucket. I'm going to assume the defaults and click on Next, and we go to Set Permissions. When a bucket is created, only the creator of the bucket has read and write access to the data in the bucket. If I want to allow other users access, I have to explicitly specify that here. If I want to allow public access, whether it's public read or public read and write access to this bucket, I have to enable that here. And if I want to allow other AWS services to write logs into this bucket, I would enable that here. Again, I'm going to assume the default and click on Next. It's going to bring up a review to tell me all of the settings I've put in for this bucket. Click on Create Bucket, and there is our new bucket. If we want to make changes to the settings that we put in when we created the bucket, we can simply click on the bucket. You can upload files. You can create folders under the Overview tab. Under Properties, I can enable versioning, server access logging. I can enable static website hosting. I can enable object logging. I can enable default encryption. Under advanced settings, I can create tags to put on the bucket. I can enable transfer acceleration. I can create events for actions to happen on the result of a file upload, for example. Or I can set up requester pays. So if somebody is accessing data from my bucket, I can determine who pays for that access. Under permissions, if I didn't set my permissions the way I wanted it, I can go in and make changes to those permissions here, whether it's a simple access control list, a JSON-based access policy document, or a cross-origin resource sharing document. Under management, I can set up lifecycle policies to move data between different types of S3 storage as the data ages. I can set up cross-region replication to copy data from a bucket in one region to a bucket in another region. I can set up analytics to understand how the data in my bucket is being accessed. I can set up metrics to understand what type of data I have in my bucket. And I can set up an inventory that will give me a full listing of all the information in my bucket. For this option, we're simply going to do an example of how you upload data to a bucket. Go to the bucket that you want to put the data in, click on the Upload button. In the Upload window, click on Add Files, select the file you wish to upload, open. In the lower left-hand corner of the Upload window, click on the Upload button, and that file now exists in that S3 bucket.
Okay, guys. So do you have any questions? Of course, the demonstration is with the old console, okay? The old console. AWS has improved the console, and now things are different, okay? The way that you see it now, before you used to see like different, it was like a card, right? A card with information like server-side encryption, tagging. Now you see like, it's a different card, right? But it's horizontal. It's not like rows of cards when you see different permissions and properties. Now it's a card, but it's horizontal. It's a different way. Okay. Do you have any questions before we break? We break for 15
No.
minutes.
No questions.
No.
Okay. So guys, let's take a break, 15 minutes break, and I'll see you back here at 10:55.
Okay.
Guys, we continue?
Yes.
Okay, so we saw the presentation here. Let's talk about Elastic File System, EFS, okay? Now, Elastic File System, like the word says, is a file system, okay? A file system is, it's a scalable elastic file storage solution. It's simple. It can be used for AWS services and on-premises resources, right? It offers a simple interface that enables you to create and configure file systems quickly and easily. And Amazon EFS is built to dynamically scale on demand without disrupting applications. It will grow and shrink automatically as you add and remove files. It is designed so that your application can have the storage that it needs, right? When they need it. Now, well, when you hear file storage in the cloud, file storage, file system, that is EFS. Don't forget that. That's EFS. It will work well with big data and analytics, right? Media processing workflows, content management, web serving, and home directories. Okay. It is the petabyte scale, low latency file system. It will work with petabytes. It's super highly scalable. Okay. You can create file systems that are accessible to Amazon EC2 instances through a file system interface. Now, guys, don't forget, this is the key word, shared. It's a shared file system. Remember when we saw EVS volumes? There's only one EC2 instance per EVS volume. Don't forget that, right? So an EVS volume can only be attached to one EC2 instance. In the case of EFS, it's a shared file system. Several EC2 instances can have access to the file system at the same time. So it's a shared file system. Very important. It can scale from gigabytes to petabytes of data without the need to provision storage. Okay, so it is, like I said, it's highly available and scalable. So thousands of Amazon EC2 instances can access an EFS file. Thousands of Amazon EC2 instances at the same time, right? An Amazon EFS is designed to provide consistent performance to each Amazon EC2 instance, no matter how many they are. It's designed to be highly available, highly durable. EFS requires no minimum fees or setup costs, and you pay only for the storage that you use. Okay. Right. It supports network file system NFS version 4 and version 4.1. Okay. And it's compatible with all Linux-based AMIs for Amazon EC2. Okay. It's compared for Linux only because in the case of Windows, it will use FSX for Windows Server. That's a different system. But for Linux, it's NFS. Okay. So the architecture is very simple. Okay. Although it takes some steps, but it's simple. It may be a little confusing, but it's simple when you think about it. Okay. So you have an EFS file system, right? And then you mount that, or you put it in a mount target, which is a network interface, right? In every availability zone. Okay. So when it's mounted there, then all of the instances in every single availability zone right here, they can access this network interface. Of course, when you create an EC2 instance, a network interface is created. right? Network interface is created. This represents an EC2 instance. So all of these EC2 instances here, here, they can access this share file. Okay. Now you can create you can have 6 mount targets. You can have, in the case of, because the mount targets depend on how many availability zones are available in a region. In the case of Northern Virginia, we have 6 availability zones, which means that you can have 6 mount targets. Right here, we have only 3 because most of the regions have 3 availability zones. If I'm not mistaken, the only one that has 6 is Northern Virginia. So you can have 6 mount targets, and inside those 6 availability zones, you can have thousands of servers, right? And they will be able to share the same file system, okay? Which makes this guy super, super excellent, okay? Okay, so how do you create that? How do you create that? Well, you create the Amazon EC2 instances and launch them in a VPC, right? And then you create the file system. You create your mount targets in the appropriate subnets. You connect your Amazon EC2 instances to the mount targets, verify the resources and protection of your AWS account, right? What are the things that you need for that? Well, you need a mount target, and in the mount target, you're gonna have a subnet ID, the security groups, 1 or more per file system. You're gonna create in a VPC subnet, 1 per availability zone, and must be in the same VPC. That's the mount target. Okay, and you can have tags like key value pairs. Now, the next thing here is the takeaways, guys. But I want to create the targets. Okay, let me create you. There's a demo, but I want to do it myself so you guys can see it. Okay, because I want you to see something. You know, I don't want you to see demos only. I want to create my own file system. Right. I'm gonna start just cleaning my computer so it can be have less things here. Okay, so I'm gonna come to my console. Okay, so let me delete a little some things here. Okay, good. So going to my console, I have the CLI here. Now, as I'm using Northern Virginia, because I'm gonna use Northern Virginia now, I'm gonna go to the EC2 instances, right? EC2 instance. I'm gonna use Northern Virginia, right? So I'm going to create six EC2 instances in different availability zones, and that's why I'm gonna open 6 terminals. Okay, so I think I have 1, 2, 3, 4, 5, 6. I have 7. So I'm gonna open 6, and what this represents is that I'm going to SSH into the 6 instances and test how the 6 instances can access the same file system. Okay, so let me see if this key is working. Let me go back to my here and see if I have these keys here. Keys, my new key pair, Perfect. So I'm going to go to where that key is, which is in the desktop. It's in my desktop here. Okay, let me do the same with all of them, right? Right. You guys paying attention?
Yes.
I'm gonna clear the screen.
Yes.
Clear the screen. I'm gonna say desktop, right? Clear the screen, right? Desktop, clear the screen, and desktop. Okay, if I only have 3 availability zones, I should do it with 3, okay? But in this case, we have 6, okay? So now I'm gonna create 6 instances, okay? I'm gonna create the first one, right? And the first one is gonna be a Linux. Remember the EFS is for Linux. So I'm gonna create Linux. I'm gonna keep the default value here. I'm gonna say 1, and then I'm gonna enable auto assign public IP. And then this was gonna be in 1A. So you can see 1A, first availability zone, okay? Now, you see this network interface is created for me. Perfect. Come here, storage, same thing. Tagging, I'm gonna say name US is 1A server, right? Perfect, right? Continue security group. Now I'm going to create a security group, right? That name is, I'm gonna call it NFS security group, okay? Miami-Dade College, community college, right? And I'm gonna say NFS and FS security group, so I can identify it. And then I'm gonna leave port 22 open because I'm going to SSH. And the next port that I need to open is port NFS. So NFS, look for NFS here. NFS, where is it? NFS, which is port 2049. NFS is network file system. That's the port that has to be open for my instances to work with NFS. So this allows access via port 22, and this one allows access via port 2049. Perfect. So we continue. Now we can launch the instance. We're gonna select this new key pair that I have, and the instance is launched. Okay. So I'm gonna go back and create one in 1B. Okay. So I'm gonna create one in 1B. I have to do this 6 times, guys. Okay. So this one is gonna be enable, perfect, and it's gonna be 1B. Okay. Perfect. Perfect. Add storage, and then we say add tags, and then the tag is gonna be name, and it's gonna be USB server. Perfect. So now we just go to security group. We select one that exists already. I select this one. Perfect. We launch it, and then we select the key. It's launched. Now I'm gonna do the same with 1C, right? 1B, 1C, 1A, and then I'm gonna do that. I'm gonna just move fast. You guys know already how to do this. So now I'm gonna select 1C, right? 1C is perfect. Everything is perfect. Storage is gonna be the same. Tags is gonna be name. I'm gonna say C, right? And then security group, select one that exists right here. Open, launch, select key, launch. I'm gonna go for the next one now. Now I'm gonna create D. So I'm gonna, for D, select this, just leave it the way it is, enable, D, and then everything is fine, right? Storage, tags, name it, and then this, D, and then configure security group, select one that exists already, it's right here, view, launch, and then this, okay? I'm gonna go for E now, E, right? And now I'm gonna create E, same thing, okay? Then it's gonna be 1E, right? Guys, if you think this way, these EC2 instances are like 50 or 60 miles apart from each other, okay? Now tag it, it's gonna be E, and then continue, launch it. Did I select the correct? No. Okay, very important. Launch here. E is done. I'm gonna go for F now, and that's it. We're done with that. I'm gonna go for F, and then we go for F here. Just next, configure details. That's enable, and then F here. I think that's fine. Continue storage, add tags, name, and then this is F, right? F, and then continue the group. Select the group that we have already. Then launch, and then T, and that's it. So I have all the instances here, the ones that I need. Okay. So 1A, B, C, D, E, F. Okay, perfect. Now what I have to do, I have to grab the IP address because that's the way that you SSH into an instance. So we're gonna go for 1A, right? And grab the IP address, the public IP address, go here and say SSH. And then I can think that I can use this because I've done it before. The name of the key is EC2-user, and then the IP address. I do this, I say yes, and then I'm logged in my EC2 instance. So I just clear, become a root user, right? And that's it. That's all I need for now. I'm gonna do the same with this one now. And now I need the IP address of the second one, okay? So I'm gonna do the same here, SSH, same key, log in here, say yes, and I'm logged in here. I clear the screen, become a root user, right? Root user, clear the screen here, perfect, okay? Come back here, get the other public IP. What I'm doing is logging in my EC2 instance, okay? That's the way you do it, SSH, right? SSH, public IP, I say yes, and I'm logged in, clear, become a root user with sudo I, and then clear the screen again. I'm a root user now. I'm gonna do the same with the other one, and then here, we're gonna do SSH, change the IP address, and then say yes, right? I clear the screen, become a root user, right? Clear the screen again, right? Come back here, grab the other one, okay? And now I just SSH, change the IP address, say yes, and then I clear the screen, become a sudo user, a root user, and then clear the screen again, right? Then I come here, grab the other one, right? And then here, I just do SSH, I just type this, say yes, clear the screen, become a root user, right? And then I clear the screen, and I'm logged in all the EC2 instances as a root user. Okay, perfect. I'm logged in. Okay, now I'm gonna come here. I'm gonna come here to, let me open a different tab here. I'm gonna come here and go to EFS, which is here, EFS, right? Now, in EFS, I'm gonna create a file system, right? I'm gonna call it My Saturday Class EFS, just that way, okay? It's gonna be in the default VVC, right? Create it, perfect, right? So it's creating, it's available now. Now I can come click on it, and then I can come to the network section, and it's created the mount targets. As you can see, there are 6 mount targets in each availability zone, okay? Just like we saw in our PowerPoint here, right? It's created the mount targets in every availability zone. There are 3 here, and here there are 6, okay? Soon they will be available. We just need to wait, okay? Let's wait for that to happen. Okay. Okay. So, in the meantime, I'm going to install something in the EC2 instances. Okay, so I'm going to install this guy, right? Okay, clear. So I'm just installing the Amazon util EFS util. Okay, that's a package that's going to help us mount the target there. Okay, so I'm going to install that in every single availability zone, right? Right. Perfect. Every single instance has that. Okay, it's a package that I have to install, so we can get this ball running, right? Okay, waiting for that guy to.
I'm sorry, where you get that code for the package?
That code I can paste it on Slack. Okay. Right? That's the code. Right? Now that this is available, right? Now this is available, I have to manage it. Right? And then what I'm going to do is change the security group because we have to open this port 2049. So I'm going to select the security group that I selected before. It's right here. Okay? So the first one is done. The second one is done. Right? The third one is done. Right? The fourth one is done. The fifth one is done. And then the sixth one is done. Okay, perfect. Now we save it, right?
Hold on, sir. Yes, please delete that. There you go.
Okay, so we save it. And it's saved. Okay, security group. Now what I have to do is come back here, and you say here it says attached, attach. So we're gonna attach the file system. So we're gonna copy this guy. You see this folder here, EFS. I have to create a folder named EFS. Okay, so I'm gonna copy this guy. I don't need sudo because I'm already a root user. Okay, so I'm gonna copy this guy. Go back to my CLI and say just create cd EFS. Not cd. Sorry. Make dir. That's make directory. Create a directory. EFS. Okay. I created a directory named EFS. Make dir EFS. Make dir EFS. Make dir EFS. Right? Make dir EFS. Make dir EFS. Perfect. Now I just have to copy what I paste what I copied from here, right? I already have the folder. It's gonna mount it in that folder. So I say this. Let's wait. It's mounted. Do the same here. Mounted. Do the same here. Mounted.
What do you mean by mounted?
We just mounted it. Mounted the file system in the folder. We just put it there. It's like adding it, enabling that there in that folder. So here, mount, using the mount command, okay? We're mounting the file system, which is FS0AA831 in that folder, in that target. It's right here. This is the ID of the file system. If you take a look here, we're just mounting in that target. It's like here, just mounting the file system in the target. We're putting it there. Now, if I just go to that CD, navigate or move to that folder, I see that the folder is there, okay? But let me show you here. I can do ls, and we have the EFS file, the EFS folder, right? ls means list, okay, guys? List. So I'm listing whatever is inside that directory. So EFS, just there, right? So let me create, I'm inside the EFS folder right now, right? And how do I navigate it to that folder? By putting EFS, I'm inside, sorry, CD EFS, I'm inside the folder right now. Right here it says it, right? Now, if I create just a file, touch, this, guys, this is Linux, okay? You use touch to create a file, right? And I call it test.txt. I just created a file. I do ls and the file is there. You see it? The file is there. What if I do ls here now? I see the file here too. What if I do ls here? I see the file here too. You're gonna see it now. It's right there. What if I do ls here? I see the file here. If I do ls, I see the file too. And if I do, I see the file here. You see, the 6 availability zones have the file. I created in one, and I can see it in the 6 of them. Let me create another file. Let me say touch, test, or let me say touch, look at me.txt. Okay? If I do ls here, is there, look at me. If I do ls here, is there, look at me. If I do ls here, is there, look at me. You see, all the EC2 instances, they have access to the same file and to the same file system. You see how cool it is? How cool this is? So I can do whatever I want here, and I would take it. Let me create an executable real quick. Executable.sh. sh is the extension for executable files. Okay, so let me say echo, which is to print. Echo, I am awesome. Okay, I save it with Control O. Save it right here. Control O. Right. I exit with Control X. Okay. Now, if I take ls, I see that my executable has been created. It's right there. Now, if I say sh executable, I see I am awesome. Right. I'm just executed the file. Now, if I do the same here, sh executable, I'm awesome. SA executable, I'm awesome. sh executable, I'm awesome. You see, guys? sh executable, I'm awesome. And sh executable, I'm awesome. This, maybe you see it in my computer, there's six instances of the terminal open, but what this means is 6 availability zones with one EC2 instance each. This, between this here, even though there's a line and is in the same monitor, between this and this, there are 50 or 60 miles difference in distance. And all of them have access to the same file system. Okay? Now, if I want to delete all the files, remove all the files that has extension txt, then I do that. Well, let me clear here. I can do this, right? Right?
rm-r star.txt.
Oh, right. I forgot the star. So now, yes, but this is not working. Okay, that happens regularly. Let me remove. Let me remove the folder. So, rm r EFS. EFS. Oh, because I have to get out of EFS.
Yeah, you're in the directory.
Yeah. So, into directory. Don't worry. I can remove them easily. So whatever I want to do here, now if I do ls, still there. I can do it later, but that's not the point. The point is that whatever I do here, right? Whatever I do is going to affect the 6 availability zones. Okay. So is it cool, guys? Is it cool? Isn't it cool?
So question, the reason why you can't remove it is because there's 5 other zones that's in the folder. So
no. Just like I create one here and it affects all of them, I can remove one here and it will be removed in the other ones. Okay. But let me see if I can say executable, just to specify the one that I want to delete. Because I'm not in the, okay, because that's probably not, okay, ls. Oh, it removed them all. They're gone.
That was just a confirmation to remove. It did remove them.
Yeah, they're gone. Yeah, they're gone. They're not there anymore. You see? They're gone. All right. So that's how it works, guys. So what I do here, I can just go ahead and just delete my EC2 instances real quick because I don't want to be charged. Sorry. So I just terminate them, right? And immediately I'm gonna be logged off my CLIs. You see? It just closed the connection for all of them. All right. So now let me go back to the EFS system. It's gonna tell me that is a destructive action, but I don't care, right? You see? This is a destructive action that cannot be undone. Well, I don't care. Okay. So, but in a production account, that's important. Okay. And by the way, it's encrypted. See here, it's already encrypted. So everything that you guys do there is encrypted. Okay. So do you like the demonstration? Do you like it?
Yes, it was very good.
Yes, thank you.
Yes. Thank you.
So
Very
there's no need to run this demo here. Okay. No need to do that. Okay. So Amazon EFS provides file storage over a network, perfect for big data and analytics, media processing workflows, content management, web serving, and home directories. Fully managed service that eliminates storage administration tasks, accessible from the console, an API, or the CLI, You can also create file system from the CLI. It scales up or down as files are added or removed, and you pay for what you use. All right. So as you could see, I added 3 files, right? I could have added 20, 25, 30 files. Okay. And I just removed them in one availability zone. I need to remove them all of them at once. Okay, because they're connected to each other. There's one folder, EFS folder, which every single availability zone possesses, right? So whatever you do in that EFS folder is gonna just propagate through all the availability zones and affect each of them, whatever you do in one. Okay. So let's talk about Glacier. Glacier, okay.
Quick question, Mr. Otano.
Go ahead.
EFS has auto scaling by default, right?
Yes.
And for EBS, you have to enable.
Well, EFS doesn't have auto scaling. It's just that it's scalable. It's highly scalable. It's scaled by itself, but it's not called auto scaling. It's just scalable. It just expands as you add more files.
Okay, I get you. So you don't set a size for EFS. You just say, oh, this is an EFS point, and you just put your data there. It'll grow and shrink automatically.
Correct.
But EBS you have to enable auto scaling.
Or EBS doesn't have auto scaling. Auto scaling is for EC2 instances. EBS is automatically replicated within the same availability zone, but it doesn't have auto scaling. You don't call it auto scaling. It's just that it scales. Auto scaling is a service for EC2 instances and also for DynamoDB, right? Auto scaling is a service. You don't use auto scaling for EBS volumes. Do you see what I mean? It's just a matter of terminology.
Are you
use the wrong terminology. It scales by itself, but it doesn't have auto scaling. You know what I mean? Because auto scaling is a service that you have to implement, right?
Okay.
But it's highly scalable. The more you add, in the case of EFS, the more files you add. It's like Amazon, like S3. The more you add, the more it expands, right? Okay, Glacier. That's a class from Amazon S3, okay? Well, Glacier is for archiving. Guys, when you use Amazon S3 Glacier for archiving, you can store your data at an extremely low cost, right? Even in comparison with Amazon S3 standard. But you cannot retrieve your data immediately when you want it, okay? And like I said before, it has 11 nines durability, right? 11 nines durability. It supports the encryption of data in transit and at rest through secure sockets layer, SSL, or transport layer security, TSL. Now, in the case of S3 standard, encryption is optional. So you can have it or not. You can have it or not, right? When you create an S3 bucket, right, by default, it's not encrypted. It doesn't have server-side encryption. So you can leave it like that and not do anything, or you can simply enable server-side encryption. In the case of S3 Glacier, it's already encrypted. It's encrypted by default, right? It's not optional, right? It's by default. You don't do anything with S3 to encrypt, with Glacier to encrypt it. It's already encrypted when it's there. You don't have to do anything. And with S3, right, with S3, you don't create a bucket. You create a vault, okay? You create a vault. And you're going to see a demonstration later, right? You create a vault. Now, you can move the objects to an S3 Glacier using a lifecycle policy, or you can simply upload them directly, right? Through the APIs and SDKs, all that. But you have to make a difference. There's a vault for archive, and there's a bucket for S3 standard. Okay, and the other guys too, S3 standard, S3 standard, S3, IA, one zone, all that. Glacier is the one that has a vault. Okay, now there's something, a concept of vault lock, which is a feature that enforces compliance through a policy. Let's say that you want to archive, and of course, when you the files that you store in Glacier, they're not called objects anymore. They're called archives, right? They're still objects because it's an S3 block, an S3 storage, class storage, but they're called archives. Okay. Now, if you want your archives to be preserved and intact, because there's an audit coming to your company, they're going to audit your company, and you want your files to be intact. You don't want someone to tamper with the files. You can use a vault lock, and no one will be able to access it, to access those archives. So that's this feature of vault lock. Okay, it's extremely low cost design. The design works well with long-term archiving, right? So like I said before, an archive is an object such as a photo, video file, a document. It continues to be an object, but it's called an archive. A vault is a container, right, where you store, archives, right? When you create a vault, you specify the vault name and the region where you want to locate the vault. You can also have a vault access policy, just like you have a bucket policy, right? That determines who can and who cannot access the data that is stored in the vault, and what operations users can do, right? Can or cannot perform, right? One vault access permission policy can be created for each vault to manage access permission for that vault. Okay. So each vault can have one vault access policy and one vault lock that is attached to it. And the vault lock is not, the vault lock is just a policy. And remember, the policies are JSON documents that you can attach to something, to an entity, and then that will either allow or deny access to the resource, right? Now, like we spoke before, it provides three options for access to archives: expedited, standard, and bulk. Retrieval times range from a few minutes to several hours. Guys, do you remember the retrieval times? Remember?
Yeah, 3 to
What
5 minutes expedite, 7 to 12 bulk, and standard.
Okay. What? Say that again. The expedited, how long?
3 to 5 minutes.
The expedited is 1 to 5 minutes.
1 to 5. Okay.
Expedited is 1 to 5 minutes. Standard?
1 to 5 hours. I don't remember.
3 to 5 hours. 3 to 5 hours. And bulk is
5 to 12 hours.
5 to 12 hours. Okay. So 1 to 5 minutes, right? 3 to 5 hours and 5 to 12 hours. Don't forget that. We're gonna see it now. Okay. So that archiving means that although you can store your data at an extremely low cost, even in comparison to Amazon S3, you can now retrieve your data immediately when you want it. Okay, Amazon S3 standard, right? S3, you're gonna get it immediately, right? Okay, so now here you can configure a lifecycle policy, just like we did before, guys, right? Just like we did before. So I can come back to my, and this is the gone, very good. So I can go back to my S3, and this is terminated. Perfect. I don't want to be charged for anything. Okay. So you can have in this particular bucket, let me see what I have here. Let me delete these two guys. And I can just type permanently delete. And then I can delete the bucket as well. Okay. Come back here to buckets. And then I can say, I want to delete this guy, right? And then I can delete this guy. It's gone, right? So now I can say here, maybe I want to create a lifecycle rule here, right? Under management, right? And then I can say, give it the name of my lifecycle rule, right? And then I want to transition current versions and previous versions too. Why not? Right? Right? So this is something that you guys create one time, and it will apply to, this rule applies to objects in the bucket, okay? Okay, acknowledge that. And then I would say, I wanna stores class. So I wanna send it to this guy because already, right now it's in standard S3 after 30 days, right? I want to add another transition, and I want to say I want to send it to Glacier after 60 days, right? And also, as I'm doing this to the current versions and the past versions, I have to do the same for the past versions too, right? And then I'm going to do this to Glacier, right? After 60 days. Right? So this is going to be like a flow of how it's going to work. Day 0, objects uploaded. They're going to be there for 30 days. And after 30 days, they're going to be, after 60 days, right? They're going to stay in the standard IA for 30 days. And after 60 days, they're going to be sent to Glacier. Okay?
Question. Question, Mr. Otano.
One more, please. And then number of days expire, let's say it's 365 here. And here I'm gonna say 365. All right. So after 365 days, they're gonna expire, and the current versions and then the previous version are gonna be permanently deleted. Yes, sir. Go ahead. Go ahead.
So my question is, these have to do with the age of the objects, not when the objects were last accessed.
What do you mean? This is for every single object in my bucket.
Right.
So-
but I'm saying that the rule applies to the age of the object as opposed
Correct.
to last access.
This is based on age.
Okay.
Okay. So after 30 days, after you unload, you see the day 0 when you unload it, right? After 30 days, it's going to be moved automatically to standard IA, right? And then you're saving on cost, right? Because it's less frequently accessed. After 60 days, where it's going to stay there for 30 days, after 60 days, it's going to be moved to Glacier. And then after 295 days, is that correct? No, 305 days, it's going to be moved or deleted, expire and deleted, right? So I now create the rule, and that's what it says here. My lifecycle rule, it will be applied to my entire bucket, right? So current versions and previous versions, they're going to transition to IA, then to Glacier, and then expires. You see? That's it. That's it. I don't have to do anything else. So every single object that is uploaded to this bucket, it will be affected by this lifecycle rule. Okay.
Can you create a life cycle for the last modification if it hasn't been modified for a year versus the age of it?
I mean include the well, it says previous version and current versions. Everything, any modification would be included here too. Because there's something called versions that I can enable. You see here, properties, versioning. You see versioning here? I can do versioning, right? Enable versioning, right? So versioning is enabled. It means that it will save a version of every single file that I save. Right now, I don't have anything. I do have this one. So if I list the versions, it doesn't give it a version ID because this was updated before. It was uploaded before I enable versioning. But if I load something else, let me add files here. Just anything, maybe this one, no, the one, not the one, this one. I can open this, I can upload it, and then if I take a look at the bucket, all the objects, I have here that this one was updated. But if I take a look at the versions, it created a version of this guy and it gave it a version ID. So that's going to be included in the management of my lifecycle policy because it says current versions and previous versions, right? Now, let me do something, guys. Let me do something here. Let me create a file. Let me delete all these guys here, right? We close these guys here. So I am in the desktop now. Let me create a file. Let me say touch. Well, we say nano, my file, .txt. Okay, so I'm gonna do this. So that has content. I just save it, and then it's right here. If I do ls, I would be able to see that guy somewhere. I put a lot uppercase so I can identify real quick. It's right here. Okay, so I want to upload that to my bucket, right? So let me go back here to the objects and upload that bucket, that file. So I'm gonna just come here and look for. It's right here, right? So I upload that guy. It will create a version of that guy. If I go back to the bucket, take a look at that. It created a version of that guy with a version ID. Of course, the guys that are created before the versioning was enabled don't have a version ID, right? I'm going to modify that file again. So I'm going to say nano, and I'm going to add more content to it. Okay? So I just modified it, right? Save it, and I will upload it again, right? So I'm gonna look for it. It's my file, right? It just accepts it. Okay, it doesn't change anything here. The file is already there, right? If I take a look at the files, it's not gonna have 4 files. The file's still there. Of course, it updates the last version. This has more. But if I take a look at the versions, you're gonna see that I have another version here. Okay, and it gives it a different ID, right? Let me do it again. So let me put some more stuff there so you guys can see one more version there. Okay. Okay. Good. So now I have, if I go back to the objects, right? The regular objects, these are the versions here. The regular objects. This one is 138 bytes, right? Let me upload the same file again. Right? Now it has 190, right? So what it didn't upload the file again. I mean, like added the file, it just modified it. But if I take a look at the versions, I have one more version with a different ID. So the lifecycle policy is going to apply to everything, same previous versions and current versions, because that's what I selected when I created the lifecycle policy: current version and previous versions. Okay, so what is versioning good for? Well, if someone accidentally deletes your file, it's gonna protect it. First, because it had a version, and second, because I can do this, right? And I can delete it, right? And I don't think that someone is gonna delete this by accident, because you have to type delete, right? But just in case, right? If you tell me that you deleted this accidentally, I would not believe you, because you'd have to type delete, right? But let's say that you deleted it, right? Now, the file's not there anymore, but if I list the versions, I still have the versions, okay? So versioning protects you from accidental delete, right? Or someone hacks into your bucket and steal your file, you still have versioning, okay? Now, if I want to recover this guy, because it's gonna be there with the delete marker, if I want to recover it, I can just delete the marker, right? I can delete the marker, and guess what? Anyone will think that it will disappear forever. No, it goes back to what it was before, right? It's right there again. Okay, it was not there before because I deleted it, right? And it put a delete marker on it. The delete marker is not here anymore. So it's gonna go back to what it was. Okay, so that's how versioning works.
Are you still charged for the storage even if you delete it?
Right, you are. I mean, even if you delete it, what do you mean? Because the marker is there?
Yes.
Yes, yes. The marker is stored there. Okay. You're gonna be charged for gigabytes per month, whatever you have. But you know, this is 100. This is 132 kilobytes. That's nothing. Or this is 190 bytes. That's nothing. Okay. And of course, in my free tier account, I'm not gonna be charged anything because I have 5 gigabytes per month for 12 months. Okay. So this is not gonna incur any charges for 12 months. So you guys understand the lifecycle policy?
Yes.
Yes.
Yes. So I'm going to delete it because I don't need it, right? Right. So I disabled it, and now I can go ahead and delete it. Okay. Now, do I have server-side encryption? Yes. So it means that all my files are encrypted. If they were not encrypted before, but as they are uploaded to this file that has server-side encryption by default, all of them are encrypted. So if I take a look at one of them, right? Let me see. Let me take a look at this guy. And I see that they are more size here. They are encrypted. Okay, they are encrypted, right? So this is the, and you can see the versions here, right? The version here, current version, okay? And because I took a look at the current version, I can click on this version here. I can say it says current version and then the previous versions, right? Yeah, they're all encrypted. Okay, they're encrypted. Before it was easier to see because you can click on the file and a slide window came from the right and show you, slide out, and then they show you the information. Okay, so when would you use Glacier? Well, for media asset archiving, for healthcare information archiving, regulatory and compliance archiving, scientific data archiving, digital preservation, magnetic tape replacement, all that. Okay. How can you access? Well, you can use through RESTful web services, right? RESTful representation of state transfer that uses URLs. You can use Java or .NET SDKs or Amazon S3 with Lifecycles. That's how you can manipulate archives in S3 Glacier with these 3 ways. Okay. The Lifecycle policy, an example that I already showed you guys, you saw it, you know, S3 standard, after 30 days, S3 standard infrequent access, after 60 days, a Glacier, and after 365 days, delete. That's called a lifecycle policy. That's how you move all the objects from one place to the other based on the age of the object. Right? Comparison side by side between S3 and Amazon S3 Glacier. Okay, there's no limit to the amount of objects that you can upload. Okay, it's unlimited. Now, the average latency, well, the average latency is milliseconds for Amazon S3, and it takes minutes or hours for Amazon S3 Glacier. The maximum you can upload per object, it's 5 terabytes maximum, right? Per object, and Glacier is 40 terabytes maximum. So it's bigger, right? Much bigger. You can save more. Yeah, the size of the object can be up to 40 terabytes. The cost per month is going to be higher for Amazon S3, and it's going to be lower for Glacier. So Glacier is a lower, it's a more affordable and cost-efficient option, storage option. You're going to build per put, copy, post, list, and get, all of these operations here, but you only build per upload and retrieval. Those are the only things that you can do with Glacier, upload or retrieval. You can see here that it's cheaper to retrieve it from Amazon S3, but it would cost you more for Glacier. Okay, and this is per request, and this is per request and per gigabyte. That's why it's more expensive. Okay, so what are you doing? You're bringing it, okay, you're retrieving it. That's right. So this is one retrieval. It's going to cost you, but how much are you retrieving? You're going to be charged for that too. Okay, so again, no limit for each of them. This will take you milliseconds to have it. This will take you minutes or hours depending on the retrieval option that you choose. 5 terabytes maximum per object for S3, and 40 terabytes maximum per object or per archive for Glacier. It's going to be more expensive to store in S3, right? And it's going to be cheap compared to S3 in Glacier, right? The operations are put, copy, post, list, and get. Operations that you can do. You're going to be billed by that. And this way you're going to be billed by upload or retrieval. It's going to cost you less to request an object from S3 than to request it from Glacier, okay? Because it's per request and per gigabyte, okay? Just remember that, guys. Server-side encryption, like we said, in S3 Glacier is encrypted by default. And S3 is, you must enable it. I did, and you guys saw it. I enabled it, okay? Okay. So you can upload from the corporate center, you can upload from the cloud, okay? Your applications on Amazon EC2 instances, and then you put it in Glacier or in S3, depending, and that's the description, that's how it's gonna be. You don't have to work on encryption here. It's already encrypted, you have to enable here, otherwise it will be disabled by default. Okay. Security with Amazon S3. Well, like I said before, you can control the access with IAM, right? And you can remember that you have IAM policies, and to be able, for one service to be able to interact with S3, it needs to have a role, and a role has a policy that allows that particular service, let's say EC2 instance, to interact with S3. You need a role, right? An IAM role. Also, Amazon S3 Glacier encrypts your data with advanced encryption standard 256. The 256 means that's the length of the key, which is 256 bits. That's the length of the key that standard advanced encryption is using, right? And also Amazon S3 Glacier manages your keys for you, is fully managed. The keys is AWS keys managed for you, right? Well, takeaways here. Amazon S3 Glacier is a data archiving service that is designed for security, durability, and extremely low cost. S3 Glacier pricing is based on region. Its extremely low cost design works well for long-term archiving. The service is designed to provide 11 nines of durability for objects. Do you guys have any questions before I do this?
No.
Let me show you.
No.
Let me show you this demo.
Welcome to this demonstration video on Amazon S3 Glacier. In the AWS Management Console, you click Services, scroll down to Storage, and highlight S3 Glacier. Amazon S3 Glacier provides 11 nines of durability, just like Amazon S3. You create a vault, and in that vault, you can store backup or archival data, such as compliance data, or use it to replace your magnetic tapes. You can create an archive, and that archive can be 40 terabytes in size. And you can have as many archives as you want within your vault, meaning that you basically have unlimited storage. You are charged per gigabyte per month, and it's a lower price than you would be charged in Amazon S3. So if you have infrequently accessed data, or you're required to store data a number of years based upon some regulation, then Amazon S3 Glacier is for you. Data in is free. Data out is charged at various rates. And I say various rates because it depends on if you're sending that data to the internet or you're sending it to a different Amazon service. So make sure that you check aws.amazon.com and search the web page for Amazon S3 Glacier, and there is a pricing guide there. All of your vaults are replicated across multiple availability zones, thereby ensuring your data integrity. To create a vault, just click Create Vault. You would select the region. In this case, I'm using US East in Northern Virginia, and I'd give it a vault name. So we can call this Compliance 2019. Click Next. I can set up notifications to let me know when certain S3 Glacier jobs are complete. In this case, I can do it with a new SNS topic or enable notifications to use an existing SNS topic that is created within my AWS account. In this case, I'm not going to create any and just leave it as do not enable notifications. Next step gives me a review, and I go ahead and click Submit. One of the things to understand within Amazon S3 Glacier is that you don't access it through the AWS Management Console. You can access it through the command line interface, the AWS CLI, or a third-party tool.
So guys, that's all you need to know when it comes to Glacier. All right, guys, so let's do this case study. Okay, let's see what we can get from here, okay? We don't have much time to do this the proper way, but let's do this. So a data analytics company for travel sites must store billions of customers' events per day. They use the data analytics services that are in the diagram. The following diagram illustrates their architecture. They have Amazon API Gateway, Amazon Kinesis. You know, this is for real-time ingestion of data. Lambda is to, you know, run the code and process operations. They also have Elastic Container Services. It's a container service. Amazon Kinesis again. Amazon Kinesis Data Warehouse. Firehose, I'm sorry. And then this is a service that is part of the Kinesis service. And what it does, it just, after the data is analyzed, transformed, what it does is just, it loads the data in a service, in a storage service. You don't have to answer that, okay? I'm gonna show you what are the places where Kinesis Data Firehose stores this. And this is not, it's just like a case study, but it's not in the scope of this exam. You just need to know what Firehose is, right? This is another case study, and a collaboration software company processes email for enterprise customers. They have more than 250 enterprise customers and more than 500,000 users. They must store petabytes of data for their customers. The following diagram illustrates their architecture. So they have a corporate data center, Elastic Load Balancer, and then Amazon EC2 instances. And then you guys can know what is the storage that, you know, EC2 instances use, you know, and we saw it before, right? But what is the file that is used to store petabytes of data? What is the storage solution? Remember when we saw the different storage solutions? Is anyone writing in the chat?
S3.
EVS, not correct. S3, not correct.
EFS.
Let's take a look. Just go back a little bit and go back to EFS. Let's see if we can find that information there. Okay. Petabyte scale. You see there? You see? Petabyte scale. Now, that could be one solution. Okay. Go back to that study case, right? They must store petabyte data for their customers, right? Enterprise customers, processes email for enterprise customers. There are more than 250 enterprise customers and more than half. Yeah. So the case for this, it could be EBS as well, right? Because we don't have, you know, they can store a lot. EBS can store a lot, okay? In this case, in the case that we have more EC2 instances and more availability zones, probably we can think about EFS, since it is a shared file system, right? It all depends on what you need, guys. If you need a file system, if you need a storage that can be shared across multiple availability zones, then you think about EFS, right? If it is only for one EC2 instance, then you use EVS. Guys, how many EC2 instances do we have here?
3.
Can we use an EVS volume with 3 instances?
No, it's only for 1. No?
No, it's only for 1. We said that one EC2 instance can have multiple EVS volumes, but one EVS volume can only be attached to one instance. So can we use EVS here?
No.
So what would we use here?
EFS.
EFS, which is a file system that is shared across multiple availability zones and EC2 instances. Okay. Here we have another one, right? So we have clients, a financial data processing and consulting company might store large amounts of data for compliance reasons. They use Amazon Kinesis for processing the data and Amazon Redshift for analysis. The following diagram illustrates their architecture. What is the storage that is used for compliance? Remember the lock?
Glacier.
Glacier. Remember the lock? We go back, a little bit back. We say that we can use this guy for compliance. So the vault lock feature enforces compliance through a policy. Okay, so what are the important things in this questions here? This case is the key words. The key words. It says compliant reasons. Okay, so what is the storage that is used for compliance reasons? Glacier. Right? Now let me show you real quick. Firehose. One moment. Kinesis. Data Firehose. Okay, so this guy is used to store in S3, Amazon Redshift, Amazon Elasticsearch service, and generic HTTP endpoints, and service providers like Datadog, New Relic, MongoDB, and Splunk. Okay, so I'm gonna paste this on Slack. You guys can take a look at it later. Okay, mostly Firehose is for big data, for the big data. Well, also for the developer, probably the architect, solution architect, but mostly for the big data certification specialty. Okay, but it doesn't hurt to know about this guy. Okay, Firehose is just, it's the easiest way to reliably load streaming data into data lake data stores and analytic services. It can capture, transform, and deliver the data. So it captures it, transforms it, and delivers it back to S3, okay? Or to S3 bucket. Any question, guys?
No.
No.
Okay, so what are the module summary of this class today? Well, in summary, in this module, you learn how to identify the different types of storage, explain Amazon S3, identify the functionality in Amazon S3, explain Amazon EVS, right? Identify the functionality in Amazon EVS, perform functions in Amazon EVS to build an Amazon EC2 storage solution, explain Amazon EFS, identify the functionality in Amazon EFS, explain Amazon S3 Glacier, identify the functionality in Amazon S3 Glacier, and differentiate between Amazon EVS, Amazon S3, Amazon EFS, and Amazon S3 Glacier. Didn't we do that, guys, today?
Yes.
We saw all this today, right?
Yes.
Okay, I still owe you a demonstration or EVS, okay? A better demonstration than the video you saw, because I want to include in the demonstration encryption of EVS volumes, okay? So complete the knowledge check. We may do that in the afternoon if we have time, right? And I have a question for you guys here, right? Sample question for the exam. So a company wants to store data that is not frequently. There you get the first keyword. That is not frequently accessed. What is the best cost-efficient solution to be considered? So the keyword is frequently accessed and a cost-effective solution. Okay, so what is it?
B, Glacier.
Glacier, does everybody agree?
Yes.
Yes.
I didn't like that. Yes, it's like, guys, you're not sure what you're saying.
Yes, it has to be Glacier, the cheapest.
Glacier is the solution. Okay, that's the cheapest solution of those four. All right. So let me get this guys here, additional resources. Right. Right. Good. And then that's the end of the class of this portion of this morning. Okay.